Here are 6 absolute value equations. Now, because the absolute value of something is always at least 0, some absolute value equations have no solution. So we're going to look at each of these equations and determine which ones have solutions and which ones don't. Basically, what we're looking for here is if an absolute value expression has to equal a negative number, then we know there can be no solution, because that's not possible. Beginning with this first equation, we see that 3 times the absolute value of x plus 2 must equal 4. Now, 4 is positive, so you may be quick to say, yes, this has a solution because it equals a positive number. But you have to consider the other stuff going on. In this case, the absolute value is getting multiplied by 3. So yes, in this case, the equation does have solutions, because 3 is positive, so you could imagine dividing both sides of the equation by 3, and then we'd have the absolute value of x plus 2 equals 4 over 3. And clearly there's nothing wrong with that. Absolute value equals a positive number. That definitely has some solutions. Really, to be sure in these problems, you want to get the absolute value bars by themselves. If the absolute value expression is equal to a positive number, there's going to be at least one solution. Moving on to the second equation, the absolute value of x plus 2 equals negative 4. In this case, the absolute value bars are already by themselves, and we see that they're equal to a negative number. That is not possible. There's no number whose absolute value is negative 4, so this equation has no solution. In equation 3, we have that the absolute value of 2x plus 3 plus 4 equals 1. Again, the absolute value expression here is not yet by itself, so we don't want to jump to conclusions. Let's just get it by itself so we can be sure. To get the absolute value expression by itself, we'll subtract 4 from both sides of the equation. Thus, on the left, we'll be left with the absolute value of 2x plus 3, and then subtracting 4 on the right, 1 minus 4 is negative 3. So now we see that this absolute value expression has to equal a negative number, and of course we know that's not possible, so this equation has no solution. In equation 4, we see that negative 3 times the absolute value of x minus 1 must equal negative 7. So let's get the absolute value bars by themselves before we make a conclusion here. Let's start by adding 1 to both sides of this equation. Then we'll have negative 3 times the absolute value of x minus 1 equals, on the right, we have negative 7 plus 1, which is negative 6. Now we can divide both sides of the equation by negative 3 to finish getting the absolute value expression by itself. Then on the left, we have the absolute value of x minus 1, and on the right, we have negative 6 divided by negative 3. Negative 6 divided by negative 3 is positive 2, because a negative divided by a negative is positive. So we have that this absolute value expression must equal a positive number. That definitely has at least one solution. Next, on to equation 5. I'll point out that with a little bit of practice, it's definitely easier to solve these without doing a bunch of work. For example, if we look at this equation, we see that negative 6 must equal 2 plus this absolute value expression. Clearly, if we subtract 2 from both sides, the left side is just going to be even more negative. It's going to be negative 8, and so there's no way that's going to equal this absolute value expression. Said another way, there's no way that we can add 2 to an absolute value expression and get a negative number, because 2 is positive, and the absolute value expression is certainly not negative. So this equation has no solution. Again, think of it like this. 2 is positive, and the absolute value expression is either 0 or positive. And so 2 plus that can't be a negative number. Moving on to the final problem, equation 6, 3 minus this absolute value expression equals positive 5. We could also just think through this equation. 5 is bigger than 3. So in order for 3 minus this to be positive 5, this, the absolute value expression, would have to be negative, so that when we subtract it, we're actually adding to 3 to get to that bigger number of 5. So there's no way this is possible, because subtracting the absolute value expression is only going to make 3 smaller. So there's no way we can subtract an absolute value expression from 3 and get the bigger number, positive 5. Hence, this equation has no solution. Note that in each of these equations, the thing inside the absolute value expression was just a line. 2x plus 3, negative 5x minus 9. These are all just lines. The problems become more complicated if we have more complicated expressions inside the bars. But for these simple examples, that's how to determine if an absolute value equation has a solution or not. Let me know in the comments if you have any questions, and be sure to check out my Algebra 2 course and Algebra 2 exercises playlists in the description for more. Thanks for watching.